Congratulations, seniors. You have made it. This is most likely, let me repeat that, most likely the very last set of notes you will have to take in Earth Science this year. Not 100% sure, but pretty sure this is your last set. Like I said, I'm not 100% sure, but most likely this is your very last set of notes you will take for Earth Science and maybe your last set of notes for science in high school. But here they are, severe storms, our very last unit here in Earth Science. First severe storm we'll talk about is the thunderstorm. It's a pretty common storm, especially here in the Midwest and the state of Missouri. It's a storm that generates lightning and thunder. That's why it's called a thunderstorm. Produces very heavy winds, heavy rain, and hail, especially this time of the year in April and May, maybe into June. We're going to have a lot of these storms, which will produce these large amounts of wind, a lot of rain, and hail. This is a perfect time of the year for a thunderstorm. They're caused by warm, unstable air. You have thunderstorms during the winter, but you're not going to have as many thunderstorms during the winter as you will in the spring and the summer. And the reason why is you have to have warm, unstable air. In other words, air that's been warmed up by the sun, by the changing of the season, but also air that's unstable, that's rising and falling because it's cooler air, but it's warming up, so it's rising. So you constantly have this rising and falling of air based on the temperature. That creates kind of an unstable environment and leads to a thunderstorm. So how common are thunderstorms? Well, they're really, really common. Matter of fact, on average here on Earth right now, there are probably about 2,000 thunderstorms happening right now. Now, that's an average. There could be more, there could be less. But on average, there's about 2,000 thunderstorms happening on Earth right now. So very, very common type of storm. As you and I both know, here in the Midwest, we have several thunderstorms that happen all the time. But on average, there's about 2,000 thunderstorms happening at any given time here on Earth. About 45,000 thunderstorms happen every day on Earth. So again, a very common type of storm is a thunderstorm. Is it severe? Yes. Is it dangerous? Absolutely. You probably don't want to get struck by lightning, but they're pretty common thunderstorms, and they're not as severe as, say, a tornado or a hurricane. The United States, about every year, is going to have about 100,000 thunderstorms. So once again, a very common thunderstorm, especially here in the Midwest. There are a lot of them. About 2,000 thunderstorms happening right now on Earth on average. About 45,000 happen every day. Now this is worldwide every day, about 45,000. And then here in the United States, about 100,000 every year. So there's a lot of thunderstorms going on at any one moment, either here in the Midwest or nationwide in the United States or even worldwide. So thunderstorms, how do they form? What is their formation like? Well, first of all, like I mentioned earlier, you have to have warm air. That's why you're not going to see a lot of thunderstorms in the wintertime, because as you know, the wintertime it's cold, so you're not going to have that warm air. As it warms up in the spring and as we get into the summer, you're going to have this warm air. It also has to be wet, humid air. So whenever you have warm air and it's humid or wet, it will begin to rise. You can see over here in the animation, you'll see these clouds are getting bigger. They're expanding because that warm air is rising. And as that warm air rises, it picks up more and more moisture and becomes unstable. 3 stages to a thunderstorm formation. Know these 3 stages. These are on your test for sure. Know them and how they all work. First stage is a cumulus stage. This is when it first starts out or when it's growing. And warm air is rising, as you can see once again over here in the animation. You can see that air is rising because that cloud is getting bigger. And that rising is called an updraft. It's simply called an updraft because up, the air is moving up, and draft stands for, obviously, air. And once again, the cloud is growing bigger. That's called the cumulus stage. Second stage is called the mature stage. This is when, just like a person, when a person is mature, they're at their largest size. Same thing happens with the thunderstorm cloud. Cloud is at its biggest, has a large amount of water, and over time, as that water begins to build up, as this cloud gets bigger and bigger, it gets too heavy. So what happens? Precipitation occurs because the water falls down. So you have rain, you may have hail, you can even sometimes have snow in some cases if the temperature is just right. But you will have precipitation because that cloud gets big during the mature stage, has a large amount of water, gets too heavy, and that water falls to the earth as precipitation. Final stage is what's called the dissipating stage, and basically the cloud begins to cool. All clouds, even though the air is fairly warm, eventually, just like everything else, are going to cool down. As they begin to cool down, basically because of the rain or the hail or whatever type of precipitation is coming down, the storm will begin to die out. Because once again, in order to form basically any storm, especially a thunderstorm, you have to have warm air. As that warm air begins to cool, as it comes down from the mature stage, the storm will eventually die. So it starts as a warm air mass and eventually will turn into a cool air mass. That's why probably if you've ever been outside after a thunderstorm, you'll notice the air is actually kind of cool. And the reason why, well, the dissipating stage of that thunderstorm has gone through and the cloud has cooled down. So the three stages, once again, know these. These will be on your test for sure. The cumulus stage, which is the first stage, is warm air rising and the cloud getting bigger. Mature stage, just like a person, the mature stage is when the person or the cloud in this case is its biggest, has a large amount of water, and you have some type of precipitation. Most of the time that's rain or hail. Finally, the dissipating stage is the last stage of the thunderstorm. It's when the storm cloud begins to cool down and eventually the storm will die. So thunderstorm formation, know those three stages. Storms usually last between an hour to 2 hours total, depending on the size of basically the air mass. Obviously, the bigger the air mass, the longer the storm's going to last. But thunderstorms really aren't that big in comparison to some other severe weather types. They only last about 1 to 2 hours. Tornadoes is kind of a step up from a thunderstorm because basically they are kind of modified thunderstorms. All tornadoes start out as thunderstorms, and they're basically just these rotating columns of air that are called vortexes. As you can see from the animation over here, a vortex is a rotating column of air. Starts out as a cumulonimbus cloud, which is in the last screen you saw that very large cloud that was growing. Those are called cumulonimbus clouds. So basically you have this big cloud with a lot of thunderstorms, and if that cloud starts to rotate, it creates what's called a vortex, and that's when you're going to have a tornado versus a thunderstorm. So tornadoes actually start as thunderstorms, but it's when that thunderstorm cloud begins to rotate or move, kind of in this circular type movement. That's called a vortex, and whenever that happens, you will have a tornado that will occur. Tornadoes are pretty common, but they're not common. They're not as common as a thunderstorm because they're bigger storms and they're more violent. In the United States, every year there's only about 770, so significantly lower number tornadoes in comparison to thunderstorms. There's a lot fewer tornadoes. Most of the tornadoes occur during this time of the year, from April through June. So April, May, and June, the air is starting to warm up. Obviously, winter's over, spring is here, and into summer, the air begins to warm up and rise, creating an unstable environment, which leads to the thunderstorms, and if they rotate, will possibly lead to a tornado. Like I had mentioned before, tornadoes basically start as thunderstorms. You can't have weather just doesn't start as a tornado. It starts as a thunderstorm. Eventually, like I mentioned, if that rotates, so that cloud begins to rotate and form a vortex, then you will have a tornado. But if you start to have thunderstorms in an area, that's when most meteorologists will start to look out for tornadoes as well. So tornadoes occur along with severe thunderstorms. They're not as common as severe thunderstorms, but they need a thunderstorm in order to start. So how does a tornado form? Well, one thing you'll notice between a thunderstorm and a tornado is they both need this warm air that's rising up, as you can see in the animation here. So you have a warm air that's rising because spring's here, summer's here, and that air begins to get warmer and warmer, and it will begin to rise. Basically, once that rising occurs, this is the difference between a tornado and a thunderstorm. The air begins to rotate or move, as you can see in the animation here. As that air rotates more and more, kind of in a circular motion, it creates what's called a mesocyclone, and this is the start of a tornado. It's what meteorologists will watch out for on radar to see if they can find, basically see if a tornado is going to occur or not. So here's your mesocyclone. It's kind of a circle. Hasn't quite touched the ground yet, and that's why it's called a mesocyclone and not a tornado. But eventually, as that air begins to roll, kind of, you have this backward, it's called a downdraft. So you had an updraft mixed with a downdraft. As it begins to have this rolling, like a ball rolling, you have up and down movement, it creates a vortex. And once that vortex goes to the ground, as you will see in this animation very shortly, that's when a tornado is officially a tornado. It's not a tornado until it actually touches the ground, and it will be called a mesocyclone, or sometimes they call it a funnel cloud. And once it turns into to the point which it touched the ground right there, kind of waiting for that, sorry about that, it will turn into a tornado, and that's when you're going to get the large wind speeds and the damage in an area. So warm air rising, it begins to rotate. It's called a mesocyclone. As you begin to get more of this rolling type of motion, you're going to create a vortex, and then a tornado is formed. So tornadoes, how are they measured? Well, they're measured with something called a Fujita scale. Fujita was just the name of the scientist that came up with this scale. It's kind of a unique scale in that it doesn't actually measure the strength of the tornado during the storm. It's a measure of the strength after. So basically, scientists will come into an area and see how much damage has happened in an area to the buildings, maybe to the landforms if it's out in the middle of nowhere. But most of the time, it's to buildings or houses. And they will give it a F or an EF rating. And the higher the number is, the more damaging it is. As you can see from this animation on the right, the higher the number goes. This is an EF3 here. You're seeing a lot more damage to this house in comparison to maybe an F1 or an F2. Scale goes from 1 to 5, 1 obviously being the weakest, all the way up to a 5, which is the most damaging tornado. Winds and some of those tornadoes can reach up to 300 miles per hour on an F5 tornado. By the way, sometimes they call it F, sometimes they call it EF. They're the same thing. So here's an example of an EF5 is what they're calling it here, or an F5 tornado. Basically, you're getting complete destruction of the entire house, meaning it's all the way down to its foundation. Everything's gone. Unfortunately, when these F5 tornadoes occur, you're going to have a lot of loss of lives with people as well. So the Fujita scale measures the strength of a tornado. It's not a scale that they use during the tornado. They actually come in after the tornado has gone through an area and kind of give an estimation of the strength of the tornado, but that's called a Fujita scale. Next one is the most damaging, most violent storm on Earth, and that's called a hurricane. These winds in a hurricane can reach up to 70 miles per hour. So you'll notice the winds actually are it's not as strong as a tornado. Tornado winds are actually stronger than a hurricane. But what's damaging in a hurricane is the water. The water is picked up by the wind, creating these huge waves, which are called storm surges, and they create a lot of damage. So as you can see from the video, the storms come on land in areas that are near the coast and create a lot of damage based on the water from the ocean, because that's where these storms get their strength. Tornado gets its strength from an air mass that's on land. A hurricane is going to get its strength from an air mass that is over the water, most of the time from the ocean. So they're much larger because the ocean's larger than land. These are called typhoons and cyclones in other areas of the world. So if you ever hear maybe a broadcast from another country or see a video from another country and you hear the word typhoon or cyclone, you know they're actually just talking about a hurricane. It's just kind of the way people call them in other parts of the world. So typhoons, cyclones, and hurricanes are all the same. They come from the strength of the water from the ocean. They're most severe, most violent storms on Earth. They're a growing problem worldwide because more and more people are living on the coasts. You may or may not know this, but water is really there's a big water shortage here on Earth right now. And so people are moving more and more to the coast so they can be near water, so they can have a supply of water. And since more and more people are living on the coast, you're going to have more damages, unfortunately more deaths, because hurricanes hit the coast because they come from the ocean. Therefore, they're hitting areas where people live more frequently as time moves on. Hurricane occurrence, they do not happen very often. They are the biggest, baddest storms, but here in the United States, on average, we only have about 5 every year. And again, that's an average, so sometimes we could have less, sometimes we could have more, but on average, hurricanes, you're only going to get about 5 every year. Just not as many hurricanes as there are tornadoes, and definitely not as many hurricanes as there are thunderstorms. There are about 85 worldwide. So once again, when we talked about thunderstorms worldwide, you're talking about several 100,000 in some cases. With a hurricane, much larger storm, much more violent, but you're not going to have as many. There are only about 85 worldwide every year. So hurricanes, how do they form? Very, very similar to a thunderstorm or a tornado because they need warm air. The difference is this: a hurricane has this warm air that's rising, as you can see in the animation, and it's over the ocean. So it's that ocean water that creates the energy for this very large storm. So again, just like a thunderstorm, actually thunderstorms are created within hurricanes, and a tornado, this storm is created by this warm air that's rising. So they start as thunderstorms, and then the warm air from the storms will move to the center, and this will create kind of more storms, creating more clouds. Then what happens is it forms what's called a ring or an eye wall. As you can see here, it's creating kind of this ring structure. This is called the ring or the eye wall, and that will begin to spin. As it spins, it picks up more and more speed, and it becomes a hurricane. And it grows and grows until basically it goes on land. Once it goes on land, the hurricane will die, and that's because it loses its steam once it goes on land because it needs warm water in order to grow, in order to survive. So once hurricanes go on land, they pretty much die out. They can keep going a little inland, but eventually they're going to die out because they don't have that supply of the warm, moist air coming from the ocean below. So hurricane formation, once again, like thunderstorms and tornadoes, they start as warm, moist air that's rising. That warm, moist air begins to spin, creating kind of this wall, which is called the eye wall because it's created from a circle. The ring continues to spin, and as it spins, it gets bigger and bigger and increases in speed eventually until it hits land and loses that moisture, that warm, wet air, and eventually dies. Hurricane intensity is determined by something called the Saffir-Simpson scale. So very similar to the Fujita scale. It's a scale that determines how strong a hurricane is, except it's called the Saffir-Simpson scale. Some scientists call it the Saffir-Simpson scale, or the SAFIR I've heard as well. So any of those will work, Saffir-Simpson scale. But what's unique about a hurricane in comparison to a tornado is the damage comes from the waves of the water. It doesn't come from the actual storm itself. The storm creates the waves, but it's these waves of the water, as you can see from this video from this hurricane here on the right. Those big waves, those are called storm surge. They come on land and they basically destroy buildings, destroy structures. Unfortunately, can cause loss of life, can cause death in people. But that's called a storm surge. So hurricane intensity is determined by something called the Saffir-Simpson scale, and most of that damage comes from the waves of the water that go across the land, and that is called storm surge. That is it, folks. Congratulations. You have taken what I believe is the last set of notes for science this year. Hopefully you've taken these notes. Show me those notes so you can get your full credit.